Okay, well, we have a special announcement to make here at the first. So some of you I see in the audience come to the annual North Carolina, the technical meeting of North Carolina astronomers. And you may remember that last year we had a fairly serious and alarming incident at that meeting. Well, I have some follow-up news about it, and I'm going to let Stan Converse tell you about that.
Hi, I'm Stan Converse, a professor of physics and astronomy at Wake Tech, at least in a former life. I'm a little apprehensive about being on campus, but very grateful to be here because the last time I was here was for NCAM back on September 23rd. I remember the date very well because that was the day I died. I had a cardiac arrest, which only 10 to 20% of people survive. But I was quickly found by Kelly Sayers and Dave Moffat. If you two would stand for a moment. I was found by them, and they performed, they dialed 911, of course, and started CPR and provided the bridge between my cardiac arrest and the arrival of emergency services who were able to restart my heart. And I want to thank you both very much. They not only performed CPR, but they did it right. So I need to also thank Dave for my 7 fractured ribs. But of course, I'm really grateful for the 7 fractured ribs because I had a full recovery and no brain damage, thank goodness. So I'm here today to pass forward this miracle and do this by way of honoring these two by establishing the Kelly Sayers and David Moffat Scholarship for Physics and Astronomy here at GTCC. This scholarship will provide $500 a semester to a physics or astronomy student chosen by the physics and astronomy faculty. In return for the scholarship, the student that receives it must learn CPR. So again, thank you very much.
What a great surprise. Thank you.
Thank you.
Stan, stay up here with us. Stay up here with us. Good morning. My name is Pam England, and I am still the new foundation director here at GTCC. I had not been on the job very long, started mid-June, and Tom was one of the first folks that reached out to introduce himself, probably no surprise to all of you all. And then in October, I get a phone call from Catherine Converse and tells me this story. And it's very rare that someone survives an episode like this, but it's also very rare that someone who knows CPR and does it correctly is close by. This was special to me personally. I have a son who served as a pool manager and lifeguard and has administered CPR twice. So I was very dedicated to try to see this through for them. Didn't know what it would end up being. Did not know I would ever meet these wonderful folks and that we would all be here together this morning with you. But it's just grown, and this is an opportunity that anyone can support. If you know these wonderful folks, if you want to support students exploring physics and astronomy at the foundation, we have many scholarships. There's not many in this area. And one of the criteria, as Stan said, is that the students learn CPR, but we have figured out a way here at the college to not only invite this student who is a scholarship recipient, but others along the way to learn CPR from our trainers at GTCC at no cost to them. So it's really exciting to be able to be here with them this morning and to be a part of. It's really hard to follow somebody that's died, but you will have opportunities throughout the day. Visit our website if you want to learn more. There's lots of stuff about the Klein Observatory and other scholarships that have been established. The QR code will take you directly to a page to support the scholarship in some way, but we will continue this forever because you've continued a life forever and you were just here participating in an event. So thank you for letting me be a part of this special moment.
Okay, so let's get on with the program. I want to make a statement here. You may notice we've got a UNCG heavy morning program, and there's a reason why if you've seen our information about this. The physics and astronomy program there is under attack from an administration that is being advised by an outside consulting group that really doesn't understand, what a physics and astronomy department can be. And so I really wanted to celebrate their program because really you would not be here today or have attended any of the TriStars if it weren't for UNCG Physics and Astronomy. And this story goes back a long way. When I was an undergrad at Guilford College in the early 80s, Steve Danford reached out to me and we put together a little project that I was supposed to work on, but didn't really work out the way it was supposed to. But I got to visit their department, meet Steve, who, if any of you know Steve Danford, he was one of our first TriStar speakers, by the way. Wonderful guy, really supportive. I got to go to Three College Observatory in those days when it was a new facility and barely working correctly. And got to take images on glass plates, which of course, the classic astronomy story that I dropped later. But find out in that environment how you could use a facility like that to reach the public and how Boy Scouts get really enamored with the acoustics of the dome when they visit. This left a real impression on me. And, now I do public outreach and teach at Guilford Tech and try to bring astronomy to people. That was really a sort of baseline idea that Steve had, was it's not just working in the classroom, you really got to interact with the public. And another thing that he did later that year is he invited me over to campus because they had Frank Drake giving a public talk. And I thought, this is cool. I've heard of Frank Drake. I've read about him in books and magazines. And I went and I sat in a little auditorium classroom. And at the end, we got to go up and ask him questions. And I had never been to such a talk before. And now that made another impression on me. And some of you know I like to bring speakers here because that's the kind of thing that that really touches people and gets them inspired. So I had never been to an observatory before I met somebody from UNCG Physics. I'd never been to a public astronomy talk before I'd met somebody from UNCG Physics. And so a lot of what we do today, the seeds of that inspiration are there. And Aaron Martin, when he first came here to Guilford Tech with a vision that he wanted to build an astronomy program, the first person he talked to really outside of campus was Steve Danford. And Steve's advice, support, expertise helped Aaron help put together the plan for the observatory that once Aaron met Don Klein, everything sort of fell into place. And so Guilford Tech's astronomy program, even before I was here, is indebted to UNCG Physics. So you never know how a program is going to touch other people in the community. And so what you're seeing here today can be traced back to some of those earliest ideas where I had a chance to interact with UNCG astronomers. And imagine if they have that much impact on just some kids in the community, what sort of impact they have on their students. you don't really have to imagine that because you're going to get to hear that in just a minute, because our first speaker today is Alicia Aarnio, who's been at UNCG for the last 5.5 years. Is that right? And I remember when she came here because Ward Howard, who some of you know, he's spoken in this room before, emailed me and said, Alicia Aarnio is coming to UNCG. You should get her to give a talk. And so I immediately wrote her, and she was one of our Stellar Society lectures a few years ago. I think the first year you were here. Maybe some of you saw that talk. So she has great connections with her students. They've been here, they've been to our in-cam conferences, they come to TriStar, they come to our public talks. She did her undergrad at Smith College and your doctorate's from Vanderbilt, if I remember right. And she was a Hale Scholar. And some of you know how important a person Hale was here, in those of us who are interested in North Carolina history of astronomy because of his eclipse expedition. But she's been at UNCG for the last few years. She's got a really active and vibrant group that's working on stellar properties and evolution. And she hopes to stay there longer, and she's going to tell you why I said that particular thing. And she's going to celebrate the work that her students are doing. So let me turn things over to Alicia and let her tell you about the UNCG stars.
This cable's a tiny bit short. Like me. Nope. Trying though.
You probably will set it as the laptop.
All right. How's that? Can everyone hear me? Is the wireless microphone working? Okay, yeah. All right. Good morning, everybody. I wish that I were here under better circumstances. As Tom described, we're experiencing some troubles right now, which I'll tell you a little bit more about over the course of the talk today. But what I really wanted to focus on was the work that my students have done over the last 5.5 years, because really that's why I'm here. That's why I'm doing what I'm doing as part of this. A little short bit of history. Tom said, oh, sorry, my talk roadmap first. So it's going to be in non-chronological order, even though I'm telling you about work over the years my students have done. I'm going to do this in more of a locational order. So we'll start close to home and talk about work that we've done on the sun in my group. Then we'll move out to stars and their disks, and then we'll move out a little farther still, the tiny mention of galaxies, because I had a particularly persuasive student. And of course, the elephant in the room is going to remain in the room. If you actually really like elephants, this is a fantastic charity that I really love following on Instagram, because they're great. All right, so 5.5 years ago-ish, about now, my husband Ron and I were hired into the UNCG physics department. It was a major investment at the time because they had been short faculty members for a really long time. And when I came and interviewed for the job and very trepidatiously told Ed Helen, well, I'm actually part of a duo, there's 2 of us, what can we do about that? He was stoked. He was really excited that we would actually get more people. So joyous, happy times. We have our little welcome gift basket here, and very good. And then 5 years later, we are experiencing a portfolio review. And periodically, I'm going to pop up slides and tell you about some of the stuff that's been going on here. And it's going to be annoying. It's going to be overwhelming. It's going to be distracting. But that's what our life has been for the last 4 months. All right, so October 6th, we had an external financial consultant named Howard Bunsis actually look at UNCG's finances. He found that the university is sound. There is no fiscal emergency. There were a few places where they could tighten up their belt, eliminate some losses, and prepare themselves better for the anticipated enrollment cliff that's coming due to the opposite of a baby boom. On the 9th, we received the first draft of the RPK group's rubric and assessment of programs. And I will note, as Tom said, they did not know how to evaluate a science program. They only counted courses that go toward our major. So they ignored everything service related that we provide to the university. Of course, we looked very, very bad on paper. The 23rd, so from the 9th to the 23rd, we had a brief window to scrutinize this entire spreadsheet of all of this data, report back if we found any errors or any inconsistencies. There were many, but the final result was pushed on the 23rd. And at this time, despite the nature of a spreadsheet itself being, a list, he claimed that there was no list of programs to be cut. All right, we were given until the 31st of that month to defend ourselves in 1,000 words, to talk about how the report had missed things that were important about our department, the value that we added to the university. 1,000 words. On the 1st of November, our faculty senate petitioned to be a part of the review process. They had not yet been talked to about any of this. They said, please let us in. The 20th of November, the undergraduate curriculum committee passed a resolution that says nobody asked us about this. Nobody tried to find out whether these cuts were going to negatively impact the curriculum at UNCG. The 21st, the day before Thanksgiving break, the chancellor says, no, faculty may not observe and participate in the review process. The 29th, our local chapter of the American Association of University Professors submitted a petition with over 3,000 signatures asking for a pause, at the very least, if not a halt to the entire process. The College of Arts and Sciences met in the following days. They had until December 1st to review these contextual statements, these 1,000-word statements. They were given 21 days to review these programs and what we had submitted. They submitted their report on the 1st. On the 5th, the College Assembly asked for more time. They said 21 days was not enough. On the 10th, the Faculty Senate followed up and said, please give us more time. And on the 12th, the Chancellor and the Provost said, no, we will not give you more time. All right, jarring transition number 1. Let's go to a moment of joy. I'm going to introduce you to some of my students. This is Aiden Lytle. Some of you might know him. I see Tom celebrating. To date, Aiden is the only student who has ever ridden a unicycle in my office. Aiden is a U.S. Marine Corps veteran, and he worked with me and faculty in the math department on analyzing sunspots. All right, so the motivation for this was the latest literature in solar and stellar activity indicates that we are overdue for a Carrington-like event. So absolutely massive geomagnetic storm that could have huge ramifications for our infrastructure, our electric grid, satellites, et cetera. And we have had a couple of interesting events recently. There was one near miss where if we had been any, even 9 days farther along in our orbit, we would have been hit by a very, very massive CME. And in 2022, there was actually a solar storm that I've put here that it caused the Starlink spacecraft to drift into Earth's atmosphere, but really Earth's atmosphere drifted into the spacecraft. It actually heated and expanded and caused $100 million in damage. All right, so Aiden says, damage, money loss. Let's try to figure out if there's something we can do about this. So he did a project on topological data analysis as a way to automatically classify sunspots. And so the idea with this is, and I will say, he was the brain trust of this operation. I told him about the solar physics part, and he did the topological data analysis part. But the idea is, with TDA, you are counting things like connected structures on different size scales, and you're also looking for holes on different size scales. So there are 2 different similarity size scales that he was looking at, things that were connected versus things that are not connected. And then as he looked across these images of sunspots and solar activity, he was able to make diagrams of how persistent features are at different size scales. So this is a new kind of analysis of these data. So we started with calcium K images because they're very nice and high contrast. We know that there are connections between sunspot group morphology and polarity and what happens in terms of geomagnetic storms and space weather. So his prediction was, if we look for the holes, because sunspots in a data set are quite literally going to look like holes in your data, then we should be able to at least distinguish the difference between sunspots and plage. So that was his first foray into this, was sort of a binary, yes, no, can we detect one of these things from the other and tell them apart? All right, so as he was doing this analysis, the actual product is a thing called a persistence diagram. So on this diagram, for every point X, there is a point Y. So if it's of size scale X, then by size scale Y, it will have disappeared. So this did not make sense at first. He had to actually do a whole set of examples to contextualize what this actually works. But what he noticed was, depending on where you looked in these images, for instance, we have quiet sun over here, we have active sun over here, they would show up in different parts of this persistence diagram. So then he could take the persistence data, bin it, and find characteristic topological shapes for these types of space weather phenomena. Now, I'm not just going to say that without giving you an answer, without actually showing you an example. These are his slides too. It was very, very funny. He put up a slide that said, "Does this work?" Yes, big bold text. All right, so a couple of different examples. This is a persistence diagram for a sunspot group. And you'll notice that for these X size scales, we have very large amounts of persistence before that goes away. So you could almost literally imagine starting in the middle of the sunspot and working your way out and comparing the adjacent pixels. Is this one like the previous or is it not? And that's what the persistence is getting at. Now, in contrast, the image that I just showed you before, plage would show up on this end of the persistence diagram, whereas quiet sun would show up on this end of the persistence diagram. So in this way, he was able to create this new classification scheme for different features on the sun. So here's an example of that binning. Over here, you can see that there's a slight filament in here, possibly something that might erupt in the future. It created a persistence diagram that looked kind of like this. And then he binned those data and turned it into curves. And so basically, wherever you see a spike in there, it's telling you something about the prevalence of a feature of a certain size scale. So he was able to train this algorithm and then go back and use just these data alone to determine what the image originally was. All right, this was his big summary. He took that project and extended it to other kinds of examples of solar phenomena. So he tried to automatically detect filaments, flare ribbons, prominences off the limb, quiet sun detections, and spots themselves. And so what his algorithm predicted was on this side. What the truth was on this side. These were all images that had already been they'd been classified by human eyes, so he knew what they were. And he trained with a fraction of the data set and then tested the remainder of the data set. And so you can see that this one-to-one line shows very, very high recovery of what the actual feature was based on his algorithm. So he had 97% accuracy. All right, so where's Aiden now? Aiden has kind of a short attention span. He's done a lot of different projects with us. He's worked with Anatoly, he's worked with my husband Ron, and he's also worked on a project with me. But he was pretty set on getting his math PhD. And that work I just described was for his master's thesis. For family reasons, he took a job with Boeing, and he's in St. Louis right now. But he wanted to come back and finish his degree. But he can't, because UNCG is also cutting the math, master's, and PhD programs. Like I said, you can't get away from it. If you saw my WUNC article, my interview, the headline was, "It's inescapable." And it really is. It's permeated just every facet of our lives for the last few months. So I apologize, I'm pulling you along for the ride. Okay, so I summarized last fall, the timeline of what happened. When we came back in January, newer, fresher hells awaited us. On January 16th, we got the first announcement. Oh wait, there actually is a list. Here's what the deans proposed to be cut. And the chancellor specifically blamed the deans. So they made the recommendations. They scheduled a series of open fora on campus. Some of these dated back to the previous semester. And this is what they called adequate discourse and conversation about the proposed changes. Fora in which they sat on the stage, declined to answer questions, condescended to people in the audience, and basically told people things instead of listening. All right, on the 17th, the Faculty Senate passed a resolution that says, hang on a second, guys, we have authority over the curriculum, and you never talk to us. All of this is a violation of any kind of policy we might have established in shared governance. The 20th, the General Education Council, which is distinct from the Undergraduate Curriculum Committee, says, hey, this is a bad idea. You're going to cut a whole bunch of electives that students need to graduate, and you didn't even talk to us about it. 3 days later, the undergraduate curriculum committee says, we vote against this. We want an extension of the process. This is at least the 4th time that we asked for more time. And at this point, only about 80 days had elapsed since we even got the data from RPK in the first place. They said, oh, we aren't rushing. We haven't rushed this process at all. Like, seriously? Seriously, nothing happens this fast in academia. Try getting somebody into payroll. Good luck. Nothing happens this fast. All right, on the 24th, our department met with the deans of the College of Arts and Sciences. Why? I have no idea, because almost all they said is, I don't know. We asked them, if we get cut, what happens to the observatory? I don't know. What happens to the planetarium? I don't know. What happens to me and Ron? I'm up for tenure this year. Ron's going to be up in 3 years. What happens to us? I don't know. But they said any of us who actually make it through teach out, if we make it, right, was this the Hunger Games? Like, if we make it through teach out, we'll be moved to chemistry and shifted to teaching only roles. What that will entail, we have no idea. What does it mean to have tenure in a physics department and get moved to a chemistry department? They don't know. They're making it up as they go along. A lot happened on this day. This was a Wednesday. That afternoon, the students had organized a rally against cuts that was held within earshot of the Faculty Senate meeting that was happening in an adjacent building. In that meeting, the Faculty Senate approved a resolution to censure both the provost and the chancellor. Because as you've seen, they didn't talk to us. They didn't respond to any requests for extensions. They didn't ask for curricular impacts, anything like that. On the 30th, our department met with the chancellor and provost. So in this period between the 16th of January and February 1st, when the cuts were supposed to be announced, they scheduled the first set of meetings between impacted programs and the university leadership. And they praised us for our professionality. So we had a really nice tone. We had a good attitude. They focused on DFW rates, which physics classes are hard the last time I checked. So of course, if you compare us to other departments in the college, it's going to be a little bit high probably. And when we asked questions like, how much money is cutting us going to save? They didn't know. How much money is it going to recoup, or how much is it going to cost cutting some of these things? They didn't know. It's supposedly a budgetary problem, but they have no numbers on budget. They also did not know how many people would need to stay, right? These mythical people who get moved to chemistry. So we need a bare minimum to offer the physics classes that are required for other majors. How many of us are you going to be able to keep? How many do you need? They didn't know. But spoiler, there are currently 7 of us, and 6 provide all of the service classes. So we knew that number. 31st, there was a Faculty Senate meeting, and they opened the floor for impacted programs to give one last plea to the chancellor and the provost to make our cases to save our programs. The undergraduate curriculum committee made yet another resolution that says, no one has talked to us about any of this yet. All right, sadness reprieve number 2. The student is Marianne Juarez. She entered in 2018 with the first class that my husband and I got as our entering cohort. This class of students is particularly special to us because they started at the same time that we did. Now, Marianne was a physics major who took Physics 101. Her confidence plummeted. She switched majors to chemistry. Then she took astronomy class and talked to me, and I was like, you can totally do physics. Come back, come back. So we stole her back. We got Marianne back. So she was very interested in astrochemistry in particular. So the project she worked with me on was looking at chemistry in protoplanetary disks. And she was motivated in particular by some observations using submillimeter interferometry, where they noticed rings of molecular species around in disks around stars. And in particular, she was, I don't remember exactly what the motivation was, but ethanol in particular was an interesting one, because in this diagram, you'll notice that there are 3 curves here. The orange and the blue are 2 different transitions of the ethanol molecule. And then the purple is the continuum emission of the disk. So what she was noticing was the phase of the chemistry in the disk was highly dependent on stellar properties. And most of the literature that we look at is looking at solar-like stars, because we're looking for the next Earth, the next place where an Earth might be in the process of forming. So she wanted to look at slightly higher mass stars. And we did this using a radiative transfer code called TORUS. It's transport of radiation under Sobolev or Stokes. And she created a grid of models to look at parameter space behavior. So a whole bunch, she numbered the stars, but the basic idea is they increase in mass and radius and temperature as you move down. And then we included some adjustments to account for the pre-main sequence phase. So their radii are still slightly inflated at this time, because that would impact the radiation heading out into the disk. So for each of these different combinations of stellar parameters, she ran multiple molecules and ended up with a huge grid of results. It actually took 2 semesters to run all of these models. Here's an example of the setup of the grid structure. This is a simple flared disk as modeled by Pascucci et al., if you're familiar with protoplanetary disks. But what you're seeing in the color coding is the density profile, and then the AMR, the adaptive mesh grid on top of it, adjusts the fineness of the grid depending on the density of where you are in the disk, so that it well samples all of the material. We calculated where the inner edge of the disk would be based on known relationships between inner disk radii and stellar temperatures and radii. And then Torres took it from there. It calculates thermal equilibrium. So this is just an initial condition that Torres takes in. All right, so her results, she learned LaTeX and summarized all of her results in a really nice paper that we still need to add all of the different species to. But this is sort of your typical, this is sort of your typical model result. It's even in the same color scheme from Matplotlib as the published paper that she was trying to replicate. And as she cranked up the stellar mass and the temperature, of course, as we expected, we noticed that the inner edge of the disk kept getting pushed out, because as the star's radiation profile gets harder, it sublimates more material closer in. It pushes that inner edge of the disk out. She made a few of these videos. This is continuum emission plus scanning through velocity space. So you're seeing the CO molecules emission at different velocities and a Keplerian profile around this disk. All right, so here were her results. She ended up making a bunch of different diagrams showing the intensity of the molecule's emission versus the distance from the center of the system. She said the disk center, but the stars is at the middle here. We found what we expected in that the inner edge kept getting pushed out as we went to higher mass stars, but unexpectedly, the outer edge moved in. All of these disks, we started at 300 astronomical units in initial size, but we noticed as we turned up the mass and the temperature, the inner edge for these molecules would come inward, which I don't have an explanation for, but my best guess is as these disks are irradiated, the material heats up, it expands, and it might be self-shielding. So maybe some of that radiation isn't getting as far out, and that's driving our frost line inward. But the real takeaway I felt of her work was we very often assume that intermediate mass stars are just slightly bigger versions of solar-like stars, and that's not necessarily the case. You do this modeling and you end up with some surprising results. All right, where is Marianne now? After she graduated, she went and worked in a lab at Clemson University, and she's going to be reapplying to graduate schools in the next round. She wanted to get some lab experience first. All right, now you might have noticed, I've mentioned a couple of things about my students. Aiden being a veteran, you probably noticed from Marianne's name, Marianne Juarez, she is Mexican, she is Latina. And this takes me to the human cost of what's happening at UNCG. Now, taking us back to January 31st, the Faculty Senate meeting, I gave a statement about the impact of our department that you can't actually measure using a spreadsheet produced by an external consultant that doesn't understand education. Some of you might have seen this before. This is from the American Institute of Physics. These are numbers of doctorate recipients in different years, doctorate degrees. You'll notice Marianne, Latina women, 10 Latina women received physics PhDs in 2018 through 2019. Another student I'm going to tell you about in a minute, his name is Kamari. If you look at Black men on this same diagram, 8. Black women, 1. When you're working at an institution like UNCG, you have the unique capability to work with a minority serving institution, a population that's 55% students of color. It's 2/3 women. Women are underrepresented in physics too. Our graduates, just in recent years, if they better make it all the way to the PhD, I will drag them myself. But when they graduate, just 2 of them will change this number, this 8, by a full 25%. And at this meeting on the 31st of January, the Faculty Senate voted also on a resolution to oppose every last one of the cuts. After I gave my statement, the adrenaline kind of got knocked out of me and I went back to my seat. And these folks who are sitting in front of me are the Dean of the College of Arts and Sciences and other deans. Most of them were on their phones for the majority of this event. Nobody turned around when I started crying. Nobody asked if I was okay. Something I remember, you know, it stuck out in my mind. All right, sadness reprieve number 3. This is my most recent student, Madison. Madison is very interested in internal dynamics inside of stars. So Madison basically looked at me and said, "What's the hardest thing you study? I want in." But that's that's on brand for Madison. So she worked with me on magnetic field generation in the interiors of intermediate mass stars. If you came to my last talk, I think I might have mentioned something about this back then. But we're motivated by this so-called magnetic HR diagram. So we all know from our intro astronomy classes that all of the properties of a star depend on its mass. And you can find this on the HR diagram. But Scott Gregory, who, shoot, I didn't put the citation on here. This is Gregory et al. 2012. He put together the interior structure and the magnetic field properties of stars and created a magnetic HR diagram. And the basic gist of it, all of the color coding is in a caption on this figure in his paper, but the basic gist of it is as you go to lower mass stars, you're reaching a higher fraction of convection in the star's interior. And when we actually map this onto observations of magnetic fields of low mass stars, we find these stars have really strong dipole moments, and they have very weak higher order moments of the magnetic field. As the radiative zone in the interior grows, as you move up on the HR diagram and to the left, the larger the radiative zone gets, the weaker the dipole moment gets, and the stronger the higher order moments get, quadrupoles, octupoles, etc. Now, we reach an observational difficulty, which is if you have strong higher order moments, you have cancellation of the magnetic field. You have things that are going north-south, things next to things that are going south-north, and they cancel out when you're trying to actually observe them through Zeeman effect and Stokes parameters and things like that. So you're very hard-pressed to get a telescope time application committee to let you look at stars when you're going to have the possibility of a non-detection. And this is an issue that I have encountered often. So to reiterate the relative strength of these moments, we have stellar mass and the x-axis, the strength of the dipole field. And as you go to higher mass, it plummets. It gets harder to detect. So I decided to model to work my way around that. And that's what Madison was working with me on. All right, so the first thing that Madison did, worked with me for a number of semesters, was funded by the Undergraduate Research and Creativity Office. Actually, all of the students I'm going to talk about today have gotten small grants from UNCG to support their research. But Madison worked with modules for experiments in stellar astrophysics, or MESA. MESA is a one-dimensional code along a radial line inside of a theoretical star. It models the temperature, the pressure, and the density gradients. It calculates where convection will be happening if the temperature gradient is just right and the density gradient is just right. And she did this as these stars were contracting onto the main sequence, which is a part of the HR diagram where it is dangerous to go because now you're dealing with compressible fluid dynamics and that gets very messy. But we tried. And so Madison created this entire grid of models, just like Marianne did, where up here we have a 1 solar mass model. In the middle, we have 4 solar masses, and in the bottom, we have 8 solar masses. The x-axis is scaled to the pre-main sequence lifetime. So 0 is the onset of collapse. 1 is when it hits the main sequence. The top line here is the radius of the star itself, and the shaded region is where convection is possible in the interior of the star at each of these points in the pre-main sequence. And the thing that I latched onto in this was we know that convection is really, really good at making magnetic fields. And along the pre-main sequence, we have times at which even these massive stars have very large fractions of their interiors participating in convection. So I'm wondering, is this where these fields initially came from? Could that be sustained for the remainder of the star's life? So the next thing that Madison started working on was trying to input these MESA models into a code called Daedalus. Daedalus is a 3D stellar structure model that includes magnetic fields and convection in stellar interiors. This is a model of Earth's interior magnetic field produced using Daedalus. And the idea, the next thing that I wanted to do with this was put MESA into Daedalus, get what the interior magnetic field structure is, set a boundary condition at the surface of the star, and then extrapolate it out from there, which I have done with lower mass stars, but I hadn't done it with intermediate mass stars yet. Now, we unfortunately did not finish, and this is one place where I'm happy that we didn't finish. Madison is graduating, and I'm very happy to let her go, go out into the world. So after some time off, she plans to seek a graduate degree. And again, we can't escape this. Madison was a physics major, or is a physics major, and a Russian minor. Russian is another one of the programs that is slated to be eliminated at UNCG. Cannot get away from it, no matter what I do. So Madison gave this quote saying it's distasteful to be discontinuing these programs and expressing some grief that these courses that shaped who she is will no longer exist. And this touches back on what Tom was saying about you never know, where the impact is going to be. But if we're gone, there won't be impact. All right, so here we are, part 3. I'm going to bring you up to the latest and greatest of the shenanigans that are going on right now. So in January, the initial cuts were proposed. The final were announced on the 1st of February. What day is it today? I don't even remember. It's March right now. And not a single program was spared from the original list. In fact, programs were added, potentially in a retaliatory fashion. But not only did they go through with every single cut that they said they would, let's see, did I put this on this slide? Within minutes of these announcements, they had already set the systems to discontinue accepting students even clicking to choose physics as a major. Within minutes. They notified the campus community, they notified incoming students, they emailed faculty and staff and current students within minutes. And again, I'm like, nothing happens this fast in academia. This doesn't make any sense whatsoever. Now, these emails that they sent out said that teach-out process was going to take years. There were going to be no immediate changes to staffing, no immediate changes to programming. 5 days later, faculty in our departments, half of our department, in fact, received early retirement buyout letters. Faculty in other departments also impacted by these cuts received buyout letters. And to this day, you'll notice I have 6 accounted for here. The university spokeswoman said 7 went out in total. Oh, it had nothing to do with the APR, but 6 out of 7 of them went to people in impacted programs. No immediate changes to staffing. On Valentine's Day, we were told that we are no longer allowed to offer astronomy classes. I heard that in the back. You're right. You are correct. We seat 600 students a year in the astronomy classes, which if they are paying in-state tuition, that's approximately $600,000 in just tuition money. And then with state appropriation, that takes it to about $1 million a year. And this is about the budget? The next week, after I complained to the press and another lecturer in anthropology complained to the press about these apparently arbitrary decisions, our lecturer was fired and the lecturer in anthropology was also fired. 3 days after talking to the press about it. I'm just going to put that factoid out there. I'm not going to connect those as causal, but if you do, I would not stop you. Now, even losing our astronomy programs, our lecturer carries a 5-5 load. There are now too many classes for us to even cover. And I think I said later, so the next week we pointed this out to the deans. We don't have enough people if you cut our lecturer. They said, we said, well, what if we make our class sizes smaller for intro physics? They said, no, just cut some lab sections and double up the rest. We said, wait, 40 students in a physics lab? Are you absolutely serious? They were absolutely serious. On the 28th, this is the only piece of maybe bright news that I have for anybody right now. This past Wednesday, we overwhelmingly voted no confidence in the Dean of the College of Arts and Sciences and in the Provost. Where this is going to go, I have absolutely no idea. But what I do know is I want to tell you about Kamari. Kamari is one of the first students who ever worked with me. In the first astronomy class I ever taught, he sat right up towards the front of the room. He wears a bow tie whenever he goes out and gives talks. And he was really interested in galaxies. So galaxies are not my purview. And I will admit I was not the best person for this job. But I said, okay. I was observing with a 3.5-meter telescope in New Mexico. And I was observing a high mass star that had a strange magnetic field behavior. And I only needed a couple hours. I had half the night. I only needed a couple of hours. So I sent Kamari an email and I said, okay, what would you like to point this telescope at? And now I'm thinking back on it. I'm like, I asked an 18-year-old, where are we going to point a 3.5-meter telescope? But he came back with actually a really intriguing idea. He said, let's point it at M82. And he almost immediately said it, like he had this object in mind. And the reason is, as you might know, M82 is a starburst galaxy. You can see jets coming off here. The rate of star formation is so high. There's a high supernova rate. There's a lot of material blowing off in the form of a galactic wind. And part of why M82 is doing this is because M81 is right next to it, and it's very massive. So we have this tidal interaction between the galaxies that is driving star formation. So what we did was we took the telescope, we pointed at a few different locations in the galaxy, and here's where my newness to observing extended objects came into play. I don't actually know exactly where we pointed the telescope. I didn't save the acquisition camera image, and that was great folly. We still had good time, and he learned a lot, but that was the idea. We were going to look and see, relative to this massive galaxy, where is the most star formation happening? So where's the most tidal squeeze happening in this galaxy? And we got something that kind of resembles results. So these are the H-alpha profiles at the 3 different points that we observed in the galaxy. To guide your eye, the line center for H-alpha is plotted here. So we see rotational motion with these lines shifting relative to line center. So we know we sampled different portions of the galaxy. So we got different bits of rotation sampled in these observations. And we also noticed different intensities of the lines, telling us something about the amount of star formation that's happening in this galaxy, the rate of it being different moving around in this galaxy. All right, where's Kamari now? Kamari is currently in the Fisk Vanderbilt Bridge program. He will be defending his master's degree this semester. This is my proud face. I'm so happy for him. He's sent out some applications to a number of other graduate schools to bridge to for his PhD, but if he chooses, he can stay at Vanderbilt and do his astrophysics PhD right there. And Kamari is among the more understated students I have ever had. He actually got pepper sprayed in the face at a Black Lives Matter protest, and he said, that sucked. So when I asked him for what he thought about what was going on here, he said, I really hate that things are not going well. All right, so the remainder of my talk, I still have one more student to tell you about and a little bit more. Out in the refreshment area, I have printed a copy of the Bunce's financial report. You can find certain pages of interest that are flagged, like the wild increase in administrative costs and the not symmetric inflation in instructional costs. You can see where the priorities of the university have been over the last few years, and it's not supporting us. This cost, we actually lost our admin assistant. We share one half-time with physics now. The biggest losses in jobs at UNCG over this time period were in administrative support for departments. So where this money is going beats me. I got no idea. Right, so the Bunce's report was really a barn burner that the university has still not substantively responded to. They have not refuted any of this other than they said, we started counting differently and that's why it looks so big. I'm like, sure, Jan, $2 equals 1 on Tuesdays for me too. All right, so at no point have they ever declared a state of financial emergency. They are using projections from during the pandemic, and that includes projected income. So they're painting the most dire picture possible to justify ramming this all through as quickly as possible. At no point have they provided any budgetary numbers from eliminating programs, what will actually be saved. The only number they have released is if the faculty accept the early retirement buyouts, that'll save $2 million, which, that just barely offsets the losses from cutting astronomy. Good job, guys. And I think the most telling point is none of these programs has yet been told why we're being cut. We have asked over and over. Why? What from the rubric did you see that said that we don't deserve to be here anymore? They have not told us. As far as physics and astronomy goes, as Tom was saying, measuring the actual input of a program, you have to actually understand what the program does. If you look at the College of Arts and Sciences, these are 25 different departments in our college. Check this out, we are number 9 in terms of the production of student credit hours per average faculty full-time equivalent. We are producing a lot for being such a small department. I've started calling us the little department that could. Anthropology was also slated for elimination. They are number 11, right behind us. And incidentally, on the rubric, anthropology met expectations. Nobody has any idea why they're being cut either. All right, my final sadness reprieve. I'm going to introduce you to the first student that I worked with upon arriving at UNCG. And this is going to bring me back home to Earth and to what we do as astronomers, as educators, as people who are enthusiastic and engaging with the public. Lindsay wanted to work on a research project in astronomy education. So she wants to understand what it is that we can do in a classroom as interventions that build people's self-efficacy, that convince them that they can do science where they previously might have thought they couldn't, things that impact their worldview possibly. And she was motivated because she took a class with me in which I showed this video. That was Carl Sagan narrating The Pale Blue Dot, speech everybody knows really well. It was set to stunning, heart-rending music, and it had all this imagery going along with it. And she noticed that as soon as that video stopped, 136 student classroom, it was packed that day, was silent. And you heard one person go, and she was like, okay, I want to understand that. I want to study that. Why did people react that way to that particular content? And can we harness that to make people believe that they can do science, that they can understand this? So her project was developed to answer a few questions. So can impactful experiences in intro astronomy courses shape the way that we view astronomy, ourselves, and the world around them? Can these experiences help support a growth mindset in students, i.e., where students don't believe that their knowledge is fixed and unable to change with time, that they are able to learn and get better at things even if they're hard? And can it make students feel more academically in control? So what she did, in conjunction with me, we kind of rigged my class and we set up impactful experiences and moments over the course of the semester. And she surveyed a group of students and asked them a set of questions. These are highlighted in a paper that she put together and submitted to Physics Education Research Journal. The third question was, did today's class impact how you feel about astronomy? And the students could answer, it didn't at all, it did a little, it did a lot. Question 5, did it impact how you feel about yourself? And question 7, did it impact how you feel about others or humanity? And you'll notice these numbers, they kind of taper off over the course of the semester. Attendance also tapered off over the course of the semester, and students' response rates also tapered off. So one important thing we learned about experimental design is we probably should have only done it for about a month, because then they get survey fatigue and the students stop responding. But they found, in particular, here's a set of examples of experiences that we set up, and I probably should have front-loaded the class with this pale blue dot video. You notice there's a spike in responses for how students feel about the universe for that particular day. Most of the reactions are closer to the beginning of the semester. We really should have run the experiment for less time. Her overall conclusion was that the experiences were most effective in affecting students' view of themselves and their place in the universe. And the particular design was if we were talking about the scales of things, size scales, time scales, things like that, the things that make you feel small. Those were the things that were the most impactful to the students. And as far as scholastic outcomes went, it didn't appear that there were many interventions we did that made them feel more in control of their education or capable in that way. So work to do there. All right, where is Lindsay now? Lindsay is another one of our tremendous success stories. She is an astrophysics PhD candidate at UT Austin. She's also an NSF fellow. She is not the only NSF graduate research fellow to come out of our department. Quentin Merritt is at Ohio State University doing physics, and he has also won that award. Now, Lindsay's work today is still focusing on astronomy education research, and she's tied it in with a dark energy experiment and created a citizen science project called Dark Energy Explorers. All right, Whew, I am right on time. This is fantastic. All right, so I deeply appreciate everybody in this room for going on this ride with me. I know that the bits about what's going on were disruptive and kind of aggravating, and they took away from the science. And that's half the point of why I did it in the first place, because that's what it's doing to us. Right? Every single day, we can't have this joy anymore of just losing ourselves in the science. Something happens, some email comes, we can't get away from it. There's a little bit of hope for us yet. Maybe we will be able to reverse this process. I don't know. We're going to keep fighting just in case there's still a chance, maybe. I wanted to close with this little remark here that I just found on Twitter. It's weird that you find something on Twitter that's deeply comforting, but this hit me at just the right time. But this woman, Louise the baker, says, "I'm almost 50, and here's the best thing I've learned so far. Every strange thing you've ever been into, every failed hobby or forgotten instrument, everything you have ever learned will come back to you, will serve you when you need it. No love, however brief, is wasted." So if my love only lasted for 6 years, it was not wasted. And neither is any of your love that you share with the public of astronomy or with your students or something like that. So thank you very much for your time and attention and support. I am not aware of those classes. Are they housed in a different school or? Okay.
So where did you get your sunspot data? Was it from SOHO or was it the satellite that got observed in the sun? Or
So he was using Big Bear Solar Observatory data. So ground-based telescope. I think it's in California. Run by New Jersey Institute of Technology. We have tried, I think a lot of the experiences I've had, people, they want to know how I feel. They want an emotional impact story, not necessarily a deep financial dive. I've tried sharing some of the research that I've done to see if somebody could pick it up and push it a little bit farther. But so far, Ian McDowell has been the most supportive in that regard. He has a forthcoming piece about how sports betting being legal is supposed to help the UNC system of schools. This was news to me, but he asked if they estimated each campus would get $300,000 in profit from this. And he said, could that save some of your faculty? I said, you assume that they want to save us. As Kamari would say, it's beyond me. Yeah, it does. They do. They do. Not really. And I myself have been really careful to try to not toss anybody under the bus. I don't think that this is necessarily an either or proposition as they're making it out to be. I think one of the places we could really be focusing on is seeing a university as a place that doesn't exist to protect its endowment, but rather that uses its endowment to protect the university. There are places there where an adjustment of less than 2% would bring us $4 million more bucks. I feel like that's a road that I don't want to comment down, but yeah, you're right. Yeah. Mhm.
Is that saying that academic programs,
Mhm.
lower part of academic programs, also
Yeah. Mhm.
political intangible? So, if you want, okay, if you want to address it, I'm trying to make it easy. For example, how different, in the red book,
Yeah. Yeah. When you treat the university as a business, you can't quantify the intangibles easily. So they just get kind of cast to the side entirely. Right.
I'm shocked that the sciences could be affected so harmfully.
Yeah.
What particular departments have flourished or have not been cut?
As far as I know, biology is the biggest. It might be the biggest program on campus, period, or in the College of Arts and Sciences. I think they have about 1,000 majors. So part of the university's argument and gambit here is, well, we'll take these funds and divert them into the big projects to keep them getting bigger. But those are largely symbolic gestures. It's not going to impact nearly as many people. I think it was to pad the list a little. Some of the things were added on there.
I have a comment and a question. First of all, thank you. My question is, do you see this as
Oh, no, no, no. So, I mean, WVU was probably the first and most obvious place where devastating cuts took place. Emporia State was the next in Kansas. Kansas University faculty have already reached out to me and said, hey, what do we do? This is coming here. UNC Asheville. Actually, right now, UNC Asheville's astronomers are in the same place we were last October. They are writing those 1,000-word statements right now. And I talked to an astronomer there, and she said, oh, I don't think we're in danger. And I'm like, do I tell her? Like, but oh yeah, this is just the beginning. Yeah. Mm-hmm. Yeah. Yeah, there was massive.
Are you seeing any of that from your alumni?
So far, not really. The alumni had one forum that they were able to join and talk to the provost and chancellor about what was going on. And I actually heard from a number of people who said they either couldn't make it because of the timing or, they had technical issues or something. The campus has largely been pretty quiet. The students broadly, if they're in unimpacted programs, which just means next to be impacted programs, don't know what's happening. The student newspaper has probably not been allowed to publish that much. They've only done 2 articles on the APR. The Student Government Association has been told they are not allowed to make comments at all. So I think the lid has been very successfully held over this whole thing. Mm-hmm. Right. Yeah.
So I'm actually up in college, and I just wanted to affirm everything you're saying.
Yeah.
It's all, yeah.
I'm sorry. Wish I needed a content warning at the beginning.
It's the same ideology. All these people go to the same conferences and learn the same, philosophy, and all of the same stuff you did. We had to write our 1,000-word statements. We went to them, and they ignored the service classes.
Mm-hmm.
We went to them and showed them that we actually made money for the school.
Yep.
And if they cut physics, it would be a net cost.
Yep, we are also revenue positive. Yeah.
It's more of a religion. They believe that small programs just can't be worth it.
Yeah.
And in our case, the alumni came through because I think our board sincerely wanted to do what was right for the college, and I don't think you're in that position.
Right.
With regard to what the authorities want, and the lack of transparency, it's all really
it's a standardized playbook, and to your question and comment, once administrations see what they can get away with. I mean, we are the first place that has not been in a state of dire financial emergency that they've just shoved this through anyway. And once other places see that what they can get away with, they have the playbook. They'll run with it. So what we need to do is figure out what is the resistance playbook. What do we tell faculty at other universities to start doing before the ball even gets rolling on the administrative side to set themselves up? Yes. Yeah. Hugely important. Oh, read more about that. Asking about science. I have a tiny bit on my website, but the MESA pages are really good. They talk a lot about the actual convection dynamics that they have implemented in their codes. Yes, there is. So this one kind of snuck up on us. The student government association, or the Greensboro Student Organization, which is mostly graduate students and interested undergrads, started talking about this website. So savetheg.com. The front page is all the latest news articles and sort of insider information. Like, I heard from them before I heard from anybody else about certain votes. So this has been absolutely awesome. And there's a bunch of tribute pages there too. So you can look at the programs that are supposed to be cut. And then there's a full documentation of all the ways that shared governance has been violated. So yeah, I would highly recommend checking that out. Yes. Yeah, and yes. It was temporarily blocked on UNCG's campus during the week until the students submitted a whole bunch of tickets to get it unblocked. So yeah, I guess it's threatening material, the news. Sorry? Right? But it doesn't matter, they're eliminating the Chinese major, so.
Change.org, and we have a QR code lobby where you can get over there.
Well, thanks, Alicia.